Welcome everybody to this edition of X Live. My name's David Cunningham. I'm one of the commercial directors of Xblue. I'll be your host today. I'm here in Paris, and I'll be joined by a colleague from the US shortly. So some of you may have seen our webinar series previously. The idea here is to come sort of live and direct to wherever you are in the world to present some of our new innovations and products. Not being able to travel obviously is causing us all problems. So hopefully we're going to be able to teach you something and inform you a little bit about what we've got here today, which is the Atlans series. So we've got about a 10-minute presentation with a colleague I'll introduce shortly. We'll have some questions after that. So if you've got any questions, don't hesitate to lodge them in the webinar application. You'll see on the right hand of the screen a facility to do that. We'll endeavor to answer all of them. And if we don't get to your question because time runs out, then please don't hesitate to contact Xblue for answers later. So Xblue, we've been making inertial navigation systems for more than 20 years, deployed in a whole range of different applications, really high performing systems in satellites for remote sensing, in submarines for underwater navigation, underwater vehicles and so on. So over this period, we've learned a great deal about the requirements of navigation and the technology that we put into our products. And this range of land and air dedicated products is something that we'll present today. I'll introduce you now to a colleague of mine, Jean-Baptiste Lacombe, who's the leader of our R&D team in our Denver facility in the US. Welcome, JB.
Thank you, David. Hi everybody.
Good morning to you. So coming back to the matter in hand, so we're here to talk about the Atlans series, land and air dedicated products. Maybe JB, you can just tell us why we've developed this new range of products.
Yeah, sure. So the idea of that new range of products come from a fact. The demand for precise positioning has exploded in the past years for autonomous navigation, for mapping, for asset management, for survey. And the sensors that were foreseen to meet that demand, the LiDARs, MEMS-IMU, for instance, they failed to meet all the requirements. So the question was, can we do something about it at Xblue? And because, as you say, we are fork manufacturer, we do the FOS, the question was really, is it possible to bring fork performance to a wider range of application? So that's what we try to do. We thought, and because we do not only do the inertial navigation system, we do the IMU, we do the sensors. We've been able to design what was, a great balance between price, performance, weight, and size for various applications. So that's the basic idea behind the new range of product.
Okay.
Bringing fork performance.
So we're talking here. We've got three products here. The range actually is a bit broader than that. Maybe you can just give a very quick overview of the range of products, Jean-Baptiste.
Sure. So the range of products is composed of 4 products called A3, A5, A7, A9. The higher the number, the better the performance. A9 that you just touched and A7 are improved version of already existing product, named Atlans and Atlans. And A3 and A5 are new products, so it's an extension of the range of product. And they all share some similar functionalities. They have, for instance, tight coupled GPS. They have the capacity to be coupled to various aiding sensors. They can operate with the post-processing software of Xblue, which is called apps. They all are able to operate efficiently without the need for dual antenna, so they can work with only a single antenna, and they share the same interfaces.
Okay, so it's a range of 4 products. 2 of them are evolutions of existing products and 2 are new products. So top of the range is the Atlans A9, this one here. Perhaps you can just give us a quick overview of that one, JB.
Yeah, so the A9 is a new version, the improved version of the Atlans. It's highest performing system in the market, and so you want to use it mainly for airborne application when running pitch is important and you go to high altitudes. Difference between A9 and Airins is that performance has been improved a little, and also you get new functionalities. For instance, the alignment is completely constraint-free. You can align your system in any condition. You don't need to be static at the beginning. You can align in flight. And you also have some new functionalities like lever calibration, so that you don't have to measure the lever arm between the GPS and the sensor. One example of application is race sailing, where the GPA and the America's Cup organizer, they use A9 in their helicopters to broadcast to the TV, the images on TV, and they use it for augmented reality, to put more information in the images. Also, it's a product that you may want to use when you want to do underground survey, when you have absolutely no GNSS. That's the kind of product you will want to use.
Okay, so the A9 then is an evolution of the existing Airins product, or the earlier previous Airins product, with additional performances, additional kind of ease of use in terms of alignment and so on, and slightly increased performances. Okay.
Yep.
Thanks for that. So next in the family then is the Atlans A7, slightly smaller. What have we got here?
So A7 is also a new version improvement of an existing product that was the Atlans. So as A9, it benefits from constraint-free alignment, lever arm estimation, and better performances than the Atlans, slightly better performances. A7 is used today for HD mapping. It's also used for people who wanted to get rid of the post-processing need, because they were able to have in real time with the Atlans the same performance they used to have in post-processing with other sensors. It's a product that's used in R&D labs, mainly automotive R&D labs, to evaluate the performance of lower performance sensors like IMU. Yeah, that's A7.
Okay, so that's the Atlans A7 is the evolution of the Atlans the Atlans C, the current product. So HD mapping being the number one application there. And now onto the A5, the Atlans A5, which is essentially something that looks exactly like that, but
yeah, exactly. So A5 has the same basis than A7. They are all, as easy to use, same operation. The thing that we did was to optimize the cost to make the A5 more cost effective. And the result is that A5 is export free. And it's a product that could be used for something like asset management. When you need precise positioning 100% of the time, but you don't need to get the same level of performance that you need for HD mapping, for instance.
Okay, so it's the same, essentially the same look as the A7, but with slightly lower performance in order to address other applications, being
Exactly.
export free. So now on to the baby of the family, the Atlans A3, very small. Perhaps you can tell us about that one, JB.
So, sure, the A3 is, as you said, the smallest. It exists in two versions, standard product, and there's also an OEM version to make it even smaller. The idea behind that was to be as small as possible, as lightweight as possible. It's 450 grams, OEM version. And it's export free, and it's an hybrid INS, so it has both fog and MEMS gyro to optimize, the ratio, weight, size, price, performance. Okay, so
obviously very, very small, available in two forms. We're not going to dig into the performances of it here, but you mentioned the hybrid IMU. Perhaps we can dig a little bit into what the rationale is there.
Well, the idea behind the A3 was that we wanted to make the product as small as possible, and yet we wanted to have fog performances. So the question was, how can we do this? And the basic idea was to keep a fog for the vertical gyro and to release the constraints on the rod and pitch axis, and to use lower cost, lower quality, and lower size and so on sensors. So.
Okay, so we've got a mix of different technologies in the different axes of the IMU. We keep a fog in the vertical axis and MEMS in the other two axes. So why do we need the Z-axis gyro or the vertical axis gyro to be? Why is that important?
Yeah, well, good question. As we can see on a coming figure, heading is very important for the performance of an INS. It's easy to understand that when you lose a GPS, or when your GPS is not as precise as you would like it to be, your positioning is going to drift. And if you've got a wrong heading, you're going to, travel in the wrong direction. So heading is a very key parameter for INS performance. The thing that maybe not everybody knows is that the heading performance depends mainly on the vertical gyro. To keep a precise heading, you need a very good vertical axis gyro. So that's why we decided to keep a very good vertical axis gyro.
Okay, so we've got a mix of gyro technologies in each of the axes, or there's a fog on the vertical axis, which gives us the better heading, which in turn gives us an interesting navigation performance. So what does that actually look like in terms of the IMU, the actual system in the A3?
So as you're going to see on the screen, you will have a view of the A3 architecture. So the A3 has a fog in the middle. That's a round box at the bottom, and around it you've got a MEMS sensor for the rod and pitch axis. You've got accelerometers. On top of it, you've got the electronical board, and as an option, you can have a very high precision GPS from Septentrio. You always have a MU block included. So as you can see, we really optimized the size and of the system to around the fog to get the best of the performance. And the interest of that is for application. I mean, it has a lot of applications, but one application that is very striking is for drone application. Removing the need for dual antenna and be able to provide a precise heading without any dual antenna is something important for light survey drones. If you go on a straight line, for instance, you will see the difference between a system that has a very good vertical fog and a system that does not.
Okay, thanks, JB. So, so essentially, we're maintaining the performance, especially in heading, with a single antenna system in a really small form factor. That's what we've achieved with this product. So, other than the range of INS systems, Jean-Baptiste, what other aspects or what other things can Xblue offer to the customers in these markets?
Well, usually customers that don't want an INS, they want a positioning solution, and they don't only want hardware; they also want service, expertise, support. So that's why we provide. For instance, we've been in the mobile mapping market for more than 10 years, and what we can see is that our customers want a complete system with INS plus GNSS. They want to use apps or post-processing software to improve the performance of the data when they can. They want to have a support, so we have a support 24 hours a day, 7 days a week. They want to have expertise to help them take the best of their system with, what's a timing issue, projection issue, and so on. So, yeah, that's what they need.
So other than the range of sensors, we've also got the post-processing software. We've got with strong training and support capability, and we can consult with any sort of integration problem from pretty well anywhere in the planet, actually.
Yeah.
But still, the INS is at the heart of what we offer, and why is the INS so important in the applications that we look at?
Well, it's about, getting to 100%. It's quite easy to have a position 90% of the time, but when you want data 100% of the time, you cannot accept, to lose some information. So, GPS can be lost if you use a LiDAR, something like that. It can be blinded, so you can also lose the information. INF is the only sensor that ensures you that you get the information you need 100% of the time. And so to get that information, to get the position and orientation 100% of the time, depends on your requirement and your application. So based on your application and your requirement, you will want a different level of INS. That's why we decided to offer that whole range of products so that you've got an Atlans for any needs you may have.
Okay, thanks, Jean-Baptiste. We're going to come to some questions in a minute, but I guess really that's the conclusion of the presentation. So there's, the summary is, here's our new range of Atlans products. The A9, top of the range for airborne applications, chiefly A7, A5, A3, and the smaller OEM version. So we've got a solution for pretty well any application in the land and airborne survey domain. And we'll move on to some questions, I think, at this point. So here we go. We've got some for you here, Jean-Baptiste. So the first question, you mentioned the constraint-free capability of the A9 in terms of alignment. Can you tell us more? And the specific question is, can I align while in flight?
So yeah, I mentioned it for A9, but it applies to all systems. So all systems benefit from that capacity. Yes, A9 can align in flight. In fact, you can align the system in any operational circumstances. If you go fast, if you go slow, the idea is that you align the system in your normal operational condition.
Okay, hopefully that answers the question. So the answer is yes. So another question so MEMS manufacturers say their IMUs are gyrocompassing. Why should I buy a FOG that is bigger and more expensive?
So there are two things here. First, what do you mean by gyrocompassing? What we call gyrocompassing is when you're able to determine precisely your heading in a static position with no movements, no GPS, no half turn, nothing. And today on the market, there's no MEMS which are able to do this. You always need movements or aiding sensors like dual antenna GPS or magnetometer, and that raises quite a lot of additional problems. So there's no MEMS for us that are gyrocompassing. And MEMS are not necessarily cheaper than FOG technology. Even FOG technology benefits from years of R&D for the telecommunication world. So our products are really based on that. They benefit from that, and they are completely competitive with a MEMS solution.
Okay, thanks. Next question about post-processing. Can I post-process the data from the Atlans with a third-party software?
So, as you know, we have a post-processing software that allows to do the post-processing of both the Atlans and the GPS and provide additional functionality like data visualization, export, and so on. You can use a third-party software, but we don't recommend it because you want to get the same performance. Because we design the sensors, we design the IMU, we know it perfectly. We have very precise model of the sensor, and precision of the model are very important to get the best of the product. So you can, but I really recommend to use our post-processing software apps.
Okay, thanks, JB. You talked a lot about heading. Why?
Well, as I say, heading is key, the key factor for the performance of the system. When you use the system to do survey, for instance, heading per se is very important. But even when you use your system to get your position 100% of the time, you will want to keep a precise heading when you lose a GPS. So if you use a solution using, let's say, a dual antenna system, when you lose a GPS, you lose your heading also. So heading is a really key element to keep the precision when you lose a GPS for airborne application, when you go on a straight line, or when, for survey or mapping, you need a precise heading per se.
Yeah, sure. So we say we offer OEM products. Does that mean we only sell to integrators?
No, we sell to everybody. Today we have customers who are integrators who buy big quantities. We also have family-owned businesses, so very, very few quantities of units. So now we sell to anybody.
Yeah, sure. Thanks for that. So now we've got one about lever arms. So do you have a module that will measure lever arms between the INS and the GPS?
Yeah, exactly. We have that in real-time post-processing. You can estimate all those parameters, so you don't have to measure anything. All the parameters that are required to get the best of the system, you can estimate them just doing a normal navigation.
Okay, so there's built-in functionality in each of the units to estimate the lever arms. So why does the Atlans only use a single antenna? What's the difference between systems that use one or two antennae?
Okay, so the need for dual antennas. Dual antenna system aims at finding the heading or keeping the heading. As I said, to keep a precise heading, you need a very good gyro. So if you don't have a very good gyro, you have a very good vertical axis gyro, you need a dual antenna system to keep the heading. But because we do have a vertical axis gyro, we don't need a dual antenna system to keep a precise heading.
Okay, but am I right in thinking that the A3 can accept a dual antenna?
So you can accept it if you want to, as an option, exactly. That allows you to have static alignment for not north-seeking system, or to increase the speed of alignment in static conditions. So product, you can use it as an option.
Okay. What happens to the current Atlans C? Is it possible to upgrade to the new Atlans A7?
Yes, it's possible to upgrade. For this, you will need to send the unit to Xblue, and you will need to, upgrade it from a hardware point of view and send it back. So it's possible for this. Please contact Xblue and to discuss it. Yeah.
Okay, thanks. So here's one about testing. Have you already tested the Atlans A5 and the A3 in real conditions?
Yes, as you know, we have customers that are more than customers. We've known them for years, so they tried our system. They accepted to be like beta testers and helped us a lot, improve a lot the system. So yes, we've been tested on the field, and so that we are sure that what we offer will meet the requirement of our customers.
Okay, thanks for that. I think that's all we've got time for in terms of questions. So thank you very much, Jean-Baptiste.
Thank you, David, and thank you to everybody who attended that webinar. Goodbye.
Bye. So there's JB. He's gone back to work. So I hope you enjoyed that short webinar. We will be posting a recording of this broadcast on our website. So if you want to show it to colleagues or relive the experience, it'll be there shortly after we're finished here. So the next webinar that we will do will be on the 28th of April concerning our DRIX USV. So we'll hope to see some of you there if that's of interest to you. We'll sign off now, but if you want to stay on the line, then we'll be showing a short video about the Exail GP deployment of our Atlans A9 on helicopters to do live broadcasting of the sailboat racing around the world. So if you have time, have a look at that, and otherwise we'll see you again soon. Bye.
JPs, it's sort of sailing redefined.
Well, this is where it's all on. 49. Phenomenal racing there.
Super fast boats right next to shore.
It's a masterclass.
It's really exciting. It's really changing our sport.
Sailing racing has a challenge when you're viewing it from the shore or on television. in that it's a field of play that's on water. There's no markings. So with Liveline, we brought that to the broadcast.
We tell all the key storytelling elements to the race, whether it's the 100-meter lines, the mark circles, the flags on the boat. All of that is possible because of the IX Blue Aerians. The Aerian sits on a special surfboard, and this is coupled directly to the camera. It's a very small, rugged, reliable unit, so it fits perfectly on the front of the helicopter. The Aerians is incredibly accurate and incredibly reliable. For heading, it gives us 0.01 degree of accuracy, and for pitch and yaw, it's 0.0005 degrees of accuracy. We need that high precision to allow us to couple the video data into the real-time space on the video screen.
Ultimately, sailing is quite a technical sport. It can sometimes be quite difficult to understand. Sometimes they're going in different directions to get to one mark. Through the graphics that we can put onto the images, it's much more understandable to the viewer.
It's one thing to be on board, but it's another to watch it. I sat down during last year and watched a couple of the races, and it was just some of the coolest footage I've seen with sailing.
Unless the audience can look at sailing and get the fundamentals quickly, we won't keep them. We use that data to really engage with the audience and tell them different stories and get them really engaged in the broadcast product.